Alright, so we are now starting Unit 3 in AP1, which is the skeletal system. Again, in your lab manual, it's a big chunk. It's from pages 63 all the way to, let's see, 103. So it's a big chunk that you got to worry about. Now, again, in the lab manual is essentially your Bible for the class, which means that you are only liable on the practical for the bones that are located in here and for the markings and the features of those bones. Nothing else. So if you start to go rogue on Google or whatever, looking up like study guides for skeletal system, you're only liable for what's in here. On your practical for the skeletal system, which will be in the future, well, yeah, there's not gonna be a pick list. Basically, it's just a bunch of empty spaces, and you gotta write in the answer or type in the answer. With that, again, I'm not grading on spelling, just as long as you're close. If you call this a femur, you're way off. So no, that'd be a no. Now, again, the stuff you're liable for the lab practical would start from page 78 all the way pretty much to the end, and it starts with this picture of the skull. Now, I will do 2 videos for the anatomy. I'm going to do one on the skull alone, and I'm going to do one on the bones that are disarticulated. You got to know them both. The skull, understand, you're looking at, your test is about, well, your test is 100 questions, and you're looking at a good third of it is the skull alone. So you really got to start pounding out and working on the skull ASAP. But these next 3 lectures that are going to be posted are specifically going over the lecture material for bones, meaning the cells that are found, the tissues that are there, how do they grow in thickness, bone abnormalities, the list goes, but you can follow the outline as well as I can. But again, the manual is going to be your best friend. Make sure you use it, because these are your have-tos, meaning have to know. Now, for lecture, this is the skeletal system, what I would call like the introduction to it, but it's not really an introduction. It's a lot of the terminology that you're going to be liable for. So, if you follow the outline that I posted on Canvas, again, osteology, just a study of bones themselves, how they grow, how they form, and the abnormalities, if they break, how they fix, the cells, the tissues, you name it. When I start going through this lecture, you can almost see the questions in front of you, I would hope at this point, where you would hear lots of comparison and contrast. Well, yeah, that's what you're going to be liable for, is comparing and contrasting. All right, so bone, osseous tissue, as you know from the previous unit, is specifically there for support. It's also going to be a repository for minerals found in your body as well too. So as you know, there are 2 types of bone. There's going to be compact bone and spongy bone. In histology, you are liable for compact bone. That's the one that have the osteon, the lacunae, the Havrasian canal, the lamellae, the lacunae with the osteocytes. You can't forget any of that, okay? Secondly, you got to understand that the matrix, if you remember what the matrix is, it is the extracellular material around it, which in this case is going to be hard. It's called calcium salts, specifically calcium phosphate, also known as hydroxyapatite, and calcium carbonate, which is chalk, which is why you see most bones kind of look, white. It's because of the calcium carbonate most. Now, for that, the second thing that's also in the bone that's going to give it resiliency is collagen. Collagen fibers are going to be corkscrewed down to the length of the bone. They act kind of like springs, so when the bone gets pushed, it's hopefully going to bend but not break and go back into position to prevent breakage. All right, so with that now, functions of the bone, you see there that I give you 6 major functions of the bone in your outline. Again, you need to know why. Basically, the reason why I put the functions of bone is, why do we even bother studying it? Why do we care? As you see there, obviously it's things like it's support. It's a framework for your muscles to attach to. It's for protection, to protect softer tissues found down below. You're going to use it for motility. With your skeletal muscles pulling on it, allows you to move. From it, when you look at red marrow and yellow marrow is where you're going to form all your blood cells, meaning erythrocytes, leukocytes. All the formed elements are going to derive from that, as well as your T cells and B cells all come from red marrow. Yellow marrow is a repository for adipose tissue, adipocytes. That's why it's yellow, because it has the pigment in it, carotene. Remember, not keratin. Keratin is the stuff that waterproofs your skin. Carotene is a yellowish, reddish orangish pigment that you'd find in fat cells, also in the stratum corneum, which is in the palms of your hands, soles of your feet. But all those are, the major functions of the skeletal system. Now, huge, big stars. Anatomy and types of bones. At a later time, you're going to be given a list of bones, and I would like you to classify them into one of the 4 categories you see in front of you. You have long, short, flat, and irregular. Those are the 4. So basically any bone in the body has to fall in one of those 4 categories. You got to be able to do that. Now, long bones simply means that they are longer than they are wide. Example, femur. It is longer than it is wide. Now, your long bones help to make up your appendicular skeleton. What is that? Those are your arms, your fingers, your legs, your toes, all that, your appendices. Okay, so what are long bones used for? Basically, think of it like a seesaw. Whenever you have people on a seesaw going back and forth, the seesaw is a lever. That's what long bones act as. They act as levers, so whenever you have a muscle pull on them, it will either redirect or amplify the force to allow for a motion to occur. So that's what long bones are for. So examples of long bones. Here we go. You have your humerus. Now if I do this supine, take my hand, flip it over, because remember that's the standard position. I got my humerus. I got, now your radius will go towards your thumb. Your ulna goes towards your pinky. Now coming up, we skip your carpals. That's a dex category. We have your metacarpals. We then have your phalanges, or also known as your digits. So 1 through 5. That's on the upper part. In the lower part, you're going to have your femur. You're going to have your tibia, which is your shin bone. To its lateral side, toward the outside, is then the fibula. Then we skip the tarsals, the ankle bones. Then you have the top of your foot, which are your metatarsals. And then we have your little tootsies. So you have those are all long bones, okay? Now, for number 2, those are short bones. Short bones are roughly the same width as well as length. Predominantly, what short bones are used for, they're usually used for sliding, gliding joints. So basically think your wrist as well as your ankle. So all your carpals, all your tarsals are going to be considered to be short bones. Third are flat bones. Flat bones are basically, they're there to cover and protect softer tissues found below them. They have like a shield. Perfect example, your skull, all those are flat bones, okay? Along with that then, your sternum, your ribs, your scapula. Also fall in that category would be your coxa, which are your hips. Trying to think of any more flat bones. I think I nailed them all. All right. Now, last group, because again, usually whenever you do lists, you have all these wonderful groups where it's, category 1, 2, 3, and then there's group number 4, other. Well, other in this case is called irregular. Irregular means that you are shaped specifically for the function with which you are designed. So, none of them have any real uniform shape, but they're designed for the function that they have. So, examples. All your vertebrae are considered to be irregular bones. Also, two very important ones that are found in your skull would be your ethmoid, E-T-H-M-O-I-D, and your sphenoid, S-P-H-E-N-O-I-D. Your ethmoid, basically if I were to take your nasal bone and rip it off, the ethmoid bone is where your olfactory nerves go from your olfactory mucosa into your brain so you can smell, okay? Now, when you pick your nose, and you can go, well, I don't pick my nose, you're a liar, everyone picks their nose. Understand, the beautiful thing about anatomy is your body puts in fail-safes. Your nasal bone stops right here, so if you go in to pick your nose, it prevents you from going further up. That's good, because there's a very thin plate right there, which you're going to find when we go over the skull, that is actually the roof of the ethmoid bone, and if you puncture through it, you're going to poke your own brain and kill you. If you ever saw like martial arts movies, like kung fu movies, if you punch somebody in the nose just right, you kill them. That's because you're shoving the ethmoid bone into the brain, killing them. That's what you do. But anytime you think of, when you think of the sense of smell, think ethmoid, okay? Now, sphenoid. Sphenoid is a large bone. It goes from one temple all the way over to the other temple, and it looks like a butterfly when you're looking at it straight on. 2 large lobes and 2 little lobes. Essentially what it's doing is connecting the left and right sides of your heads together, almost like a helmet, through basically behind your eyes, more or less. It's going to have where your pituitary gland is going to sit, but again, I'll show you that once I do the anatomy of the skull. But those two, along with the vertebrae, are considered to be irregular bones. Then going down in your list, you see that there are additional types. You have what are called sutural bones or Wormian bones. What the hell is that? You're going to need to come in a little closer. What you see here on your skull, these are immovable joints called sutures. Now, notice how some of these go back and forth, like almost like a steak knife almost. So they're called serrate sutures. Now, this one doesn't have it. So therefore, having sutural bones or Wormian bones is not a common thing. Now, if these little swivels went back and forth, and eventually in these little sutures you would see like little tiny bone chips, or back here where you have the occipital bone, if you had this huge bone chip here, that is a special sutural bone called an Inca bone. This skull does not have one. Normally when you see Inca bones, like Inca, I-N-C-A, usually you see them in skulls of Asian descent is usually where you see them. This is a fake skull, which is why it's plastic. All right, so, but anytime you would see like bones within the cracks themselves, those are called sutural bones, or like a Wormian bone. Okay, now, next one you see there is called a sesamoid bone. Sesamoid bones are found in areas where you have to alleviate mechanical stress. Perfect example, the largest sesamoid bone in your body is that. That's your kneecap. That's your patella. So the patella is an example of a sesamoid bone. Think about how much pressure you put on your knees every day at that joint. You need something to alleviate the pressure of that joint. Otherwise, you're going to cause damage. Ta-da, sesamoid bone. All right. All right, let's go next. So now this next section where it says surface markings, I cannot stress this enough. Huge, ginormous star. Highlight every GD thing here and know it inside and out. Why? The first quiz you have, which is coming up, is specifically on these terms. You have to know the features. You have to know what they mean. And as I go through this, I'm going to pull out stuff to show you what it looks like for realsies. Okay. So a fissure. A fissure is a slit through a bone. Usually for anything for blood vessels or nerve endings or muscles to go through. Give you an example. Come closer. You look in the eye socket. You notice there's a slit that goes up and back and a slit that comes down and forward. You see that? Now, those two slits are called fissures. We have the superior orbital fissure and the inferior orbital fissure, but they're slits through the bone. All right? Next, we have a foramen. Foramen means a hole, usually circular through a bone. What's it for? Again, blood vessels, nerve endings. The easiest one to remember, and if you get this wrong, I'm going to throw the damn skull at you, is this hole at the bottom. That is the foramen magnum. Now notice it's not foreman. A foreman is a guy at a job site that tells you what to do. A foramen is a hole. This is where your brainstem comes out of the base of your skull to go to your vertebral column. Okay, so that's foramen magnum essentially means big hole, the biggest hole. All right. Now, meatus. A meatus is an opening that is going to either end to a tube, which ends in a dead end, or all the way through a canal. So basically, it's think of like a tube, like a toilet paper tube. The opening of the toilet paper tube would be called the meatus. All right. Give you an example. Right there, where my finger is. That's your ear hole. That's this. That is called the external acoustic meatus. Okay. Next, a canal. A canal is a tubular passageway through a bone. Again, if I were to shove like a pencil, don't do this, through your ear, you would go into your auditory canal, going eventually to your tympanic membrane. A fossa. Fossa is a very generic word, but it's used quite a lot. Let me see. Yeah, I'll do this one. All right, so we'll just use Mr. Skull still. I'm going to take the jaw off, the mandible. All right, so fossa. Fossa is going to be a depression in a bone that's usually concave, usually flat and smooth, but it acts as an articular surface for another bone to fit into so that you can have a joint movement. Give you an example. Imagine this is a rounded edge of a bone. This is a fossa. They would fit in so that therefore I could move within that socket. Example. Coming up on the list, you're going to see this word. This is called the mandibular condyle, that little rounded nub right there. The mandibular condyle fits into this right there. That is called the mandibular fossa. when you stick the mandibular condyle into the fossa, you can now open and close your jaw. Okay? An alveolus. An alveolus, number 6, it depends upon what part of anatomy you're talking about. If you're talking about the respiratory system, the alveolus are your air sacs. We're not there yet. That's in Unit 5. Alveolus is a pit or a socket in a bone. Only time you're ever going to hear about alveolus is your tooth sockets. Those are your alveolus. Fovea. Fovea is a small little divot, almost like a pinpoint dent within a bone. Give you an example. Femur. Okay, if you look, here's the head of the femur, and there's that little indent right there. That little indent is called the fovea capitis femoris, the little pit in the head of the femur. Fovea capitis femoris. What's that for? Basically, it's for a ligament to go into your hip socket so that you keep your leg, in the socket, in your hip. All right, a sulcus. So a sulcus, in your guide, it's going to be used different ways, where they will call it a groove, they will call it an indent. Basically what a sulcus is, I have two high prominent areas of bone, and there's a dip in between them, like a valley in between them. The dip is the sulcus, okay? But they'll call it they'll call it a notch, they'll call it other things. But basically, in general, whenever you have two high points to a bone, and in between them is like a valley in between them, that valley is called a sulcus. Give you an answer. Give you an example. Right here. There's your femur, back of the femur, so your patella would be right here. If I take your leg, flip it around, you have these two large condyles, okay? But if you notice, there is a dip right there, okay? That is called the intercondylar groove. It's a common name, or it can be called the intercondylar sulcus. It's a low point between two high points. Okay, next we see a process. Process is a general term. Basically means any bony prominence coming off of a bone. Your skull is full of them. That right there, real simple. Take your finger, go behind your ear, and you'll feel a bump right there. That bump is called the mastoid process. What the hell is that for? Well, once we get to the muscle system, watch, look at me. Mastoid process, turn your head all the way to one side, and you'll feel this muscle pop up like a triangle. That muscle is called the sternocleidoid mastoid muscle. Sternum, clavicle, mastoid. It's a big triangle. One on one side, one on the other side. What's it doing? It's turning your head. You got to imagine like you're a puppet. You need muscle strings to pull the puppet around. But that's the mastoid process. Then you'll see this little tiny, looks like a little pencil sticking down. That's called a styloid process. This one that comes out in front, that is called the zygomatic process. It comes from the temporal bone to the zygomatic bone. That's the zygomatic process. So there's lots of these things that stick out. All right. Now, a condyle. Condyle I already went over. It is a bulbous, rounded prominence which usually articulates with another bone. Example I showed you, that was called the mandibular condyle. It's rounded and it pronounces out, so it can go into your jaw, so you can move your jaw around. Another one that I pointed out to you a little while ago, these were called condyles too, because this would be the inside of your leg. This is called the medial condyle. This is the outside of your leg. That's called a lateral condyle. But they're rounded edges, because understand your tibia, your shin bone, would sit just like that. And your patella would sit out in front. Okay? All right, next. Where did I leave off? Condyle, okay. Now, epicondyle. Epicondyle means a bump or a bony prominence found above the condyle. Real simple. This was a condyle, but if you notice, above it is a bump. That's going to be the epicondyle. What are epicondyles for? Specifically for your knee, keep in mind that you're going to have ligaments that are connecting bone to bone. So you have a ligament from your femur down to your tibia on both sides. The whole idea is to keep the knee in alignment so that when you walk or run, they don't go out of alignment. It basically holds them all in proper alignment with the ligaments. So, head. Head is a large bulbous extension of a bone, usually rounded. Example, I can put it down. That's the head of the femur. That's the head of the humerus. Okay, so it's a large, enlarged end, prominent end of a bone. Okay, A facet. Now, facets tend to be, people mess these up constantly. A facet is a slightly convex or slightly concave articular surface. So basically, convex means it bows in, convex means it bows out, concave means it bows in. Where do you see these a lot? In your vertebrae, because I understand your vertebrae have to slide down on top of one another in order for you to take a bow and then to sit upright again. Give an example. Come closer. For another lecture, this is a thoracic vertebrae. This is one of the vertebrae where your ribs attach to it. Now I'm going to take this would be my thoracic vertebrae looking at you. I would take this spinous process, and that's my back. That's me facing you right now. Okay? Now if I take this and I spin it around, notice there's a flat part here, and there's a flat part here and here. Well, that's because in your back, a vertebrae above will slide down on top of this one, and a vertebrae below will slide up underneath that one, so they kind of snake together. These are called intervertebral facets. This one is superior. These ones are inferior. They slide down on top of each other, all the way up. Okay? Next, tuberosity. Tuberosity is an elevated raised portion of a bone, usually found on the shaft of the bone, which is going to be called the diaphysis. Give you an example. That is a humerus. Okay, that's your upper arm. This would be your shoulder. If you were to take your finger, this part right here is called the diaphysis, the shaft. If I go to the outside edge and I run my finger down right about there, all of a sudden it was smooth, 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 and it gets just bumpy and rough and raised. That is called the deltoid tuberosity. What the hell does that mean? Your deltoid muscle, your shoulder muscle, comes here, and it comes down to your humerus to grab at that point so you can raise your arm whenever you want to answer a question. Okay, tubercle. Tubercle was a small little nub or bump on a bone. Give you an example. Back to the humerus. This is the head. Notice when I turn it, there's a bump here and a bump here. Okay? This is going to be then the, these are both called tubercles. Another very important one to have for tubercle on a rib. Now, this is the head of the rib, and this would be on my back. So basically, this would be like this. How can you tell the rib is at one end of it? If it had cartilage, is going to be like hollowed out on one end. It's solid on the other end. The solid end, that's the head. Behind the head, you notice, is a bump. That bump is called a rib tubercle. Why? Here was the thoracic vertebrae. Here is a rib bone. The head of the rib is going to hit the thoracic vertebrae right here. The rib tubercle hits it over here. Watch. Like that. Okay, so the tubercle hits this little divot right there. Okay? Which means that when you dislocate your rib, you did that, which you shouldn't do. All right. Now, next is a line. You have a line, a crest, and a spine. Okay? Now, again, they're scattered in the list, but they all kind of mean the same thing. It's just a matter of how far off the bone do you come. A line is going to be a thin little projection off of a bone that's extended, but doesn't come very far off. Give you an example. There's your femur. This would be your thigh muscles would be here. Your quadriceps would be here. If I take your leg, flip it around, your hamstrings are back here now. If you notice, there's a little thin line right there. Very thin line of raised bone right there. That is called the linea aspera. It's for your hamstrings to attach to, but it doesn't come very far off. Let's jump down a bit to number 20 to where I have a crest. A crest is huge. It's a huge ridge coming off of a bone. I'll give you an example. There's your coxa, your hips. This right here is called the iliac crest. It's this massive ridge of bone that comes off. Huge. That's big. So a line is barely off. A crest is really far off. If you go in between, the last one, number 21, you see there would be a spine. Spine means we're not close to the bone. We're not way off the bone. We're somewhere in the middle. Right here, this is your scapula. Okay, this is your shoulder blade. Now, if you were to take your hand, you'd feel this part right there on your shoulder. if you take your hand and you run it back, you'll feel this ridge that runs down your back with a muscle above it and a muscle below it. What you felt was this ridge right here with a muscle above and a muscle below. That right there is called the scapular spine. So notice it comes off the bone, but it's not huge, not a crest, nor is it real close. Is it a line? All right, let's pop back up. Number 17, a protuberance. Protuberance means any bony prominence. Most common one people can think of is what's called your mental protuberance. Your mental protuberance is your chin. That right there. Understand that means when you were inside mommy, you had gills, and gill arch number 1 fused with gill arch number 2, and that's how you got your jaw. You had to have gills or you wouldn't have had a mandible. All right, and that's that prominence. Next, trochanter and trochlea, big stars. These are very unique. Trochanters. Trochanters, big star, only occur on the femur, period. They are at the proximal surface, meaning towards your hip, right here. So you have the greater trochanter and lesser trochanter, those two big nubs. What are those there for? Massive muscle attachments to your leg. Why? Because you walk upright. You're bipedal. You need those. Now, a trochlea is something different. Trochlea is only found on the humerus, not at the proximal end, but at the distal end. This is your elbow. Now watch. I'm going to take my finger. I'm going to cover up the capitulum. That little thing in the middle, right there, that is called the trochlea. Trochlea, notice, looks kind of like a spool, like you could wrap thread around it, okay? So it's a spool-shaped condyle located at the distal end of the humerus. Why does it have that? Because you wish to raise your arm. If you remember, your ulna goes towards your pinky. The ulna has a C shape to it. It has to fit around the trochlea, so when you raise your arm, it goes up and then it goes back down. So it needs the trochlea for that notch to go around. Okay, ramus. Ramus is a flat, broad portion of a bone which is nearly perpendicular to a part of the same bone. Perfect example. Mandible, you have this part of bone right here, and then you have this large, broad, flat piece of bone that's nearly perpendicular to this one. This is called, this part, the perpendicular part, is the mandibular ramus. All right, now that's going to be for quiz number 1, those terms. All right, now moving on. Structures of long bones. Well, here we have a long bone, okay? So what we're going to do is I'm going to sketch this out for you. Let me get some of this stuff out of my way. And we're going to go over features. All right, so let's make it look a little better, shall we? Let's just start over. How about that? Okay, there's your femur. Okay, now, a couple areas you have to know. The shaft. That's called the diaphysis. That's number 1. Okay? The ends are called the epiphyses. You know all these terms I'm talking about. I'm not wasting my breath. You got to know them. Okay? Now, in between them, before this solidifies to become solid bone, if you remember, your bones have to grow. They grow from histology I talked about. This was all hyaline cartilage at one time. You ossify in the middle, and then you go toward the tips. Well, whenever you're still in your growing years, there is a growth plate going to be located here, and a growth plate located here. That's going to be hyaline cartilage. As those cells divide, the bone gets longer at the tips. Now, follow. So that means that anything in the middle is the diaphysis, the shaft. What's the shaft for? In a long bone, that's the lever for power, to have a muscle attached and to move. The epiphyses then are going to house usually specialized types of marrow cavities. They're all going to have marrow cavities. Those are specialized cavities. Now, in between them, if you notice, then, we have this zone. That zone in the middle can be called the metaphysis, meaning the area between the dia and epiphysis. In your growing years, however, they often call the metaphysis another name. They call it the epiphyseal plate. Okay? Epiphyseal plate is the area where you have your reserve hyaline cartilage. Like I said, as they divide, then the cells grow, then the bone grows longer. Eventually, you understand that the hyaline cartilage does get used up in the epiphyseal plate. You stop growing taller. And how does it stop growing? As it becomes solidified bone. When it becomes solid bone, you can't grow any taller. once you stop growing in height, this epiphyseal plate becomes what's called an epiphyseal line. It looks like a little fine crack in between where the plate was. It's the tombstone of what used to be your growth plates, okay? But that would be the metaphysis, also known as the epiphyseal plate. Now, periosteum. Let's use different colors. Peri means on the perimeter. So follow, this is bone, and then there's going to be a layer of tissue outside of it. And that's going to be called the periosteum. Okay? What does it do? It's basically a dense irregular connective tissue. It makes a sheath around the diaphysis. It's for ligaments to attach to, for muscles to attach to. But you can also have blood vessels attached to it, nerve endings attached to it. So basically it's an all-inclusive connective area is what it can be. Now, articular cartilage would be at the tips. The articular cartilage, you know from your test for histology, that's made of hyaline cartilage. Hyaline cartilage at the tips creates a semi-viscous fluid called hyaluronic acid. Real simple. Think. You take a chicken leg and you bite it. When you get to the end where there's a knuckle right there, that's that bluish white, that's hyaline cartilage. If you ever felt it, it felt kind of like this weird, oily, rubbery texture. That's hyaluronic acid, okay? But that's the articular cartilage. Now, medullary cavity. The medullary cavity, if you remember back from histology, the medulla was the middle of the hair follicle. So, let's do blue. This area is going to have a cavity in it in the middle, like that. These other ones will also have cavities here and here. They all have cavities in them. How those cavities form, it's a later lecture. But that's the medullary cavity. Often what you may have known as, quote, the marrow cavity. That's the same thing. Now, the marrow cavity or the medullary cavity, if I have a periosteum on the outside, I got to have tissue lining the cavity on the inside. So lining the tissue on the inside, then, you have another layer of tissue called the endosteum. And that lines the medullary cavities. Okay? Now, who cares? In the periosteum, you do understand your bones grow two ways. They grow in length and they grow in thickness. Length, as we said earlier, is terminal. Once you get to, say, your late teens, early 20s, you stop growing taller. That's terminal growth. However, your appositional growth in girth of a bone, that occurs your entire life. Basically, the more a bone is used, the thicker it becomes. The less it's used, it becomes thin, and those minerals are used somewhere else. So, underneath the periosteum, there's going to be two different types of cells. You're going to have what are called osteogenic cells, which are the stem cells for bone. And you're also going, so you're going to have osteogenic cells, period. My bad. I was thinking about the inside. So understand, as you get older, as you use a bone more, if you gain weight, you need to make the bone thicker. So the cells right on the outside of the shaft in the periosteum will divide, and they'll slowly make the bone thicker on the outside, laying down more bone. Well, you understand that as you get older, if your bones only got thicker as you got older, your skeleton would get heavier and heavier, and eventually you become immobile. Well, what happens then is, what should happen is, as you're laying down new bone on the outside, you're destroying old bone on the inside. And as long as that pace is kept contiguous, the bone never becomes thicker or thinner. It just stays the same thickness. Okay? Now, on the inside, you also have osteogenic cells, stem cells. Why? Well, let's just say this happened. You broke it. Wouldn't it be nice if you had bone stem cells on the outside and the inside, so as they reproduced, you could knit the bone back together at a faster rate? That's exactly right. Also, on the inside, in the endosteum, you have osteogenic cells, stem cells, and you also have cells called osteoclasts. Osteoclasts are bone reabsorbers. They kill bone cells, and they reabsorb the minerals and distribute it somewhere else. So they're basically the cleanup crew for any bone pieces or anything like that. Okay? Now, let's see how far I am. Last thing is the nutrient foramina. If you notice for number 8 in that list, a foramen was a hole, singular. Foramina means little holes, like little pinholes, and they're numerous. So what you got to imagine, you can't see it in the shaft. There's hundreds of little pinholes throughout this diaphysis. But you can't see it when you see the bone, when you look at it naked eye. What is that for? Those are for blood vessels to go into the medullary cavity, nerve endings to go in so you can flood the bone with blood so it percolates back out again. You got to understand your skeleton, you don't have blood pumped into your skeleton. It goes into the marrow cavity and like a sponge it kind of oozes back out again. How does that do that? You already know. The Herbacean canal, the caniculi, that's the little network of blood to come in and out. All right, now, diploe. Diploe, you see underneath there, underneath number 8. I didn't know where to put that. Diploe, big star, is not a feature of a long bone. Diploe is a feature of short bones, flat bones, and irregular bones. What is it? Well, if you think of like a skull, skull's a flat bone, okay? The bones are flat. What you're going to have are different types of bone represented. When this was being formed, this is basically all what's called mesenchyme tissue, which means undifferentiated tissue. Eventually, as time goes on, it starts to fill in with spongy bone. Spongy bone looks like a dried out kitchen sponge. Here. Come closer. If you notice, covering the tips, you have compact bone, but if I chip that away, you get this weird, looks like a dried kitchen sponge underneath it. That's called spongy bone. That is found at the tips of long bones, whereas the shaft, that's compact bone. That's for hardness. Okay, so the spongy bone is there to actually act, like a shock absorber. So when you're walking, it's like a little cushion underneath it. All right, so why do I point this out? Well, diploe means this. Diploe means when a flat bone, when an irregular bone, when a short bone is becoming bone, when it ossifies, when you're still inside mommy. What's going to happen is this mesenchyme tissue all becomes that spongy bone first. So you got to imagine there's a network of all these little trabeculae, which are the little shards, and they're everywhere, okay? However, as the bone gets older and older, you continue to ossify and ossify, specifically the outer layer and this inner layer. These become compact bone because you keep adding more and more bone to it, filling in the sponge holes, whereas the middle remains spongy. So whenever you see a design motif where you have compact bone, spongy bone, compact bone, that's called diploe. Example, the reason why you have it in your skull, let's just say, you do this. You didn't crack your head like a skull. What happened was the spongy layer allowed that to happen. So, I don't know if this is a fake skull. I doubt if it shows it. No. Well, it tries to. If you notice, compact bone on the outside, compact bone on the inside. They try to put like little bubbles there in the middle. Yeah. And that's the spongy, okay? So you have compact, spongy in the middle. That's diploe. All right. So, next up, histology of bone tissue. So, histology. Again, big star, be able to compare and contrast between the 4 types of cells. Osteogenic, osteoblast, osteocyte, osteoclast. Osteogenic, I already talked to you about. Osteogenic cells are bone stem cells. Where are they located? They are located in the endosteum and the periosteum. They're there whenever you need to make the bone thicker or for repair. Now, osteoblasts. Osteoblasts are bone-forming cells, meaning these are the ones that are going to make the matrix of the bone. They are the ones that actively take the calcium salts out of the blood, calcium phosphate, calcium carbonate, and actually ossify the tissue. Okay? Now, like you saw before in histology, there's a cell surrounded by a lacuna. When they are close together, like I did in the previous lecture, those are called they're called blasts. As you secrete more and more and more of the matrix, they start to come further and further apart. Once you're by yourself, you're now a cyte. So an osteoblast is when they're close together, and they're still making the bone matrix. As they lay down more and more bone matrix, the lacunae start to separate, and eventually you're by yourself. Once you're by yourself, you're an osteocyte. An osteocyte is an adult bone cell. Adult bone cells are not about bone formation. They're all about maintaining the bone's integrity, which means they require far less energy to do their job. Osteoclasts, I told you before, are the bone destroyers and reabsorbers. Osteoclasts, they're larger cells. Very characteristic shape. They're smooth on one side and they're scalloped on the other side. Okay? Why? Because understand these things are going to be giving off, give off hydronium, they're going to be giving off chloride, together makes hydrochloric acid. Hydrochloric acid dissolves the calcium carbonate, the calcium phosphate. But if you remember, in the bone, I said earlier, there's something else holding the bone together. There's collagen corkscrewed through it to give it resiliency. Well, the collagen has to disappear too. The last thing that this cell face gives off are a host of enzymes called acid phosphatases. Acid phosphatases destroy collagen. So what happens is this will give off the hydrochloric acid, the acid phosphatases, dissolve the bone, and then this scallop membrane provides more surface area to suck the minerals back in to move them somewhere else. Okay, so they're a bone destroyer and then reabsorb the minerals. That's an osteoclast. And as I said, where were they found? They were found in the end ostium. All right. Coming on down then, the matrix of bone, I already said like 10 times already. The primary thing that makes up the hardness of your bone, again, are going to be calcium salts. Here we go. Calcium salts come in two forms. Ca3PO42 is calcium phosphate. Common name is called hydroxyapatite. So if you go to a GNC or whatever, you wouldn't see that on the jar. It would say hydroxyapatite. This comprises 85% of your skeletal mass. So most of your skeletal mass comes from that mineral. However, as you notice, bones are white. They also have in them CaCO3, which is calcium carbonate. Calcium carbonate comprises 10% of your skeletal mass, hence why bones, when they're out in the sun, look white. They're bleached white because of the chalk that's in them. That leaves 5% left over. Those are for trace elements, everything from magnesium, sodium, potassium, fluorine, chlorine, other places. So understand, that means your skeleton, when you look at it, is this huge, massive reserve repository of calcium and phosphorus for your body. Why is that significant? To maintain your proper blood function, pH, nerve signaling, muscle signaling, you need a ready supply of calcium and phosphorus all the time. Okay, so coming on down then, you see that they have put the mineral salts are what give the bone its hardness. The collagen gives it its tensile strength, which means bend but don't break. You see two anomalies there, brittle bone disease and rickets. Know the difference. Brittle bone disease means the person has no problem ossifying the bone. The problem is the collagenous fibers that are holding it together are weak or non-existent. So basically, they have the hardness of the bone, but not the resiliency. So if they were to do this, their bones would, like sheetrock, they'd go into powder. They would separate. Rickets. Rickets is the opposite effect. Your collagen fibers are fine in your bones. However, you don't have enough minerals. You can't deposit the minerals at a fast enough rate, which means you can't make the bones hard. Hallmark sign of rickets is bowed legs. Bow legs because your torso is pushing down on your femur. Well, if your femur can't harden, but the collagen fibers, keep it resilient, they will make your legs bow to hold up the pressure. Okay? So, with that then, we come down then to, you have to know the difference between compact bone and spongy bone. Compact bone, I went over with you in histology. As you know, it makes up the shaft of the bone. It's more compressed. That's whenever I made the drawing of the osteon with the lacunae, herbacean canal, caniculi, lamellae. If all that sounds foreign to you, go watch the video on histology specifically about bone cells. You're liable for it. Now again, but they're found in the shaft and they overlay all the spongy bone to give it that smooth look to it. Spongy bone, on the other hand, as I said, is going to make up, we said, the body of the flat bones, the irregular bones, and the short bones. But we also found spongy bone at the tips of the long bones, again, for a shock absorber type of thing. Now, beautiful thing about spongy bone, it looks fragile. It isn't. It's the same strength as compact bone, but it only has a fraction of the mass, so it helps to lighten your skeleton as well. Now, when I showed you this before, those little shards that look like dried kitchen sponge in there, those are called trabeculae. Know that. So trabeculae are unique to spongy bone. They look like little tiny shards, like a dried kitchen sponge, pretty much. Okay. Now, let's see what else. It says blood and nerve supply. You can read that as well as I can. It's just self-explanatory for that. Now, bone marrow, this is the last thing for the introductory lecture, is bone marrow. You have to know the difference between red marrow and yellow marrow. Okay, now follow. When you're inside mommy, most, if not all, your marrow was red. Okay, all over the place. However, as you mature, red is replaced by yellow. Yellow is fat. All right, now, where do you retain, well, as I said, red marrow is made of tissue called myeloid tissue. Myeloid tissue means undifferentiated tissue that specifically are your stem cells for your bloodstream. So whenever you people like going through leukemia and they need a stem cell transplant, those are the cells they take from red marrow. They're pluripotent, which means they self-regenerate, and plus they also don't have cell fate yet. Now they can't become anything in your body. They can become any blood cell in your body, from a basophil, eosinophil, neutrophil, B cell, T cells, memories, any one. They can become any, including also looking at erythrocytes, your red blood cells, as well as your platelets, your foreign elements for clotting. Any one of them can be that. Now, whenever you're inside mommy, all over the place. However, you have to know where you find red marrow in you right now as an adult. Okay, big star. Think where your heart is, right here, okay? Think of the bones in the area around it. So, areas where you keep red marrow: your sternum, your ribs, your vertebrae, your skull, the proximal head of your humerus, the proximal head of your femur, your coxa. These parts right here retain it. All those retain red marrow. And again, your heart would be located right here, so they're all in the general vicinity. That's why when people go to see whether or not they can donate their stem cells, well, think where they take to do that, they'd literally have to punch a hole in the bone and suck out some of the marrow. It's not pleasant. It hurts. Well, you're not going to take it out of your skull, not out of your vertebrae, not out of your sternum, your ribs. You're not going to take it out of your shoulder or your hip because you're not going to walk. Where do you take it out of? Your hip. It's the one that's the most easily accessible in order to see, and then also get the blood cells. Get the stem cells. All right? So, know where they are in an adult. Yellow marrow, as you know, yellow marrow is usually found in the diaphysis of long bones. It's yellow because it's made up of adipose tissue, adipocytes. I mentioned this in histology, far more important right now. When somebody breaks a long bone, the biggest worry is not that the bone was broken. It's worrisome that if you broke the diaphysis, some of the yellow marrow, some of the fat cells could have been dislodged, and they can travel in your blood vessels in your body, cause a clot, and eventually kill that person with an embolism. Which is why when they tell somebody when they break the bone, they send them home, they said, keep an eye on so-and-so, for the next 24, 48, 72 hours. If they start showing really weird behavioral changes, bring them in immediately. Well, what is that? That's a side effect of whenever you have adipocytes started going through the brain itself, it can cause behavioral changes, which could be indicative then potentially of a clot somewhere and an embolism and eventual deaths. That's why they say keep an eye on them. All right, that ends the introduction for the skeletal system, and then the rest of the outline will be in 2 more pieces. See you then.